Here is 2.1, day 2, part 2. We did our last example where we gave you two x-intercepts. Now what's given to you is the vertex and one additional point. So we're giving you the vertex 2, 0, and then a point 0, 3, which also ends up becoming the y-intercept. So step 1, since they give us the vertex, we're going to start with the vertex form equation of a quadratic function. I'll give you some time to finish writing up that first part, and then we'll start to solve it. All right, so we need to find the vertex points. So there's our vertex, 2, 0. Remember back from yesterday's lesson, that was your H and your K. So when we talk about the H and the K, H you're going to have to kind of think opposite, that's inside the parentheses. So what's going to go right here? What's that number going to be? It's going to be a positive 2 or a negative 2? Negative 2. So our equation is going to start like this. Y equals A, and then x minus 2 all squared. And then what's my K? Where am I moving up or down? From the parent function. Where am I moving up or down? Am I moving up or down at all? Is there any transformation going on? That's just a plus 0. And now the rest of this problem is just like the previous example. We're going to find an identifiable point on the graph. We're going to plug it in to this red equation, solve for A, and then substitute A back into this red equation. So what is the additional point on this graph? Where's the other identifiable point? 0, 3. So we're going to use this point next. So step 2 is identify the A. So if you don't want to write these steps down again and start to solve it, it'll probably go a little quicker. You've seen it once already now. I still have them up there for you so you can kind of follow along. So the next step is to find the y-intercept or another identifiable point on the graph. So we said the other point is 0, 3. So this represents the x and the y in the equation. And now we're going to substitute it in. So this goes in for x, this goes in for y, and what happened to that 0? Do I really need that plus 0 there? No. The k is 0 value, so you don't need to have that 0. So that's why I kind of dropped it. Alright, so now let's go ahead and substitute the x and the y in. So the y value is 3. The a is what we're going to be solving for, that's our unknown. Our x value is 0, and then minus 2 squared. Alright, so what do we do next to solve this for a? Think about our orders of operations. square negative 2. I'm going to just simplify that parentheses. So 0 minus 2 is negative 2. And then you said to square the negative 2. So negative 2 times negative 2 is 4. And then last step, divide by 4. So we got a positive 3/4. So our graph should open up. The last step is to rewrite the equation with a in it. So y equals 3/4, and then x minus 2 all squared. If I wanted to convert it to standard form, I would have to take the time and FOIL that out to get your y equals ax squared plus bx plus c. This example has multiple answers. So for you in class, to someone else in class, you'll have different answers, and that is fine. So here's what they're going to give you in your homework. They're going to say, given these two x-intercepts below, find two quadratic equations. One of the graphs is going to open up. So I have a picture of an example of a parabola opening up. And then the other one, the parabola is going to open down. Multiple answers exist. So it's kind of like the first example we did. And then you get to make up the A. Yep, you get to make up a positive A and a negative A. So we have the x-intercepts. We're going to go ahead and identify those again. So those x-intercepts are 0 and 10. So we're going to think back to two examples ago. We have x-intercepts, so we have to have them in factored form. So remember when we used the zero product properties of those factors equal to 0 and solve for x? What's going to be in this blue, those blue underline, what's going to go in here and here? Those are going to be your opposite x-intercepts, so it's going to be plus or minus, it doesn't matter, because that's just going to cancel it anyways. And what's this one going to be? It's a minus 10. Because if I were to go and solve that, if I set this function equal to 0 and solve for x, x minus 10 equals 0, and then I add 10 to both sides, that would be my x-intercept of a positive 10. All right, so now we've written the equation in factored form. Then step 3 is you just choose a positive A, any random positive A, and then any random negative A, and then the parabola will open down. So these go pretty fast. So what do we want our A to be? You guys choose. 1? Should we make it a little more exciting than 1? No? 1? Okay. So we're going to let A be 1. So now you just throw in 1 right there. Y equals 1, x, I'm just going to drop the 0, and then x minus 10. That's it. That's part of your homework today. Now, let A be some negative number. So then now the parabola opens down. So just make up an A value that's negative. What do you want for that one? A equals, thanks, negative 3. So now I substitute in negative 3 in for there. And there are two possible quadratic functions. with those two x-intercepts of 0 and 10, where one of the parabolas opens up and one of the parabolas opens down. I will be stopping the recording and picking up on our last part.